Hi ladies and gentlemen, this video is to help you get started on practice set 3 of Unit 1 Constant Velocity. I have a motion map up here, and then remember the motion map is showing me the change in position over time of an object with a hollow circle at time 0 and solid circles at 1 second intervals after that. The first thing I'm going to do is try to figure out the motion of the object using dirt. So the direction of my object, I can see that my arrows are pointing to the right, so my direction is positive. My initial position is telling me where does my object start. I can see that my hollow circle is at 0 meters. R stands for relative speed. I can't really compare this to anything else because I only have one object in motion, but I'll just say medium in terms of its relative speed. And lastly, T stands for type of motion. And I can see that all of my arrows are the same length, so I'm going to say that my object is moving at constant velocity. All right, next up is I am going to try to represent the motion with a quantitative position versus time graph. The way that I'm going to start this, I'm going to put a dot at position 0, time 0. And then I see at time 1 second, I'm at position 2 meters. Now I need to scale this first. So I'm going to say this is 2, 4, 6, 8, 10. But then down here, I don't see a dotted line there, but I know it is there. Time 1, time 2, time 3, time 4, time 5, and so on. And then 0, 0 at my origin. So at time 1 second, I'm at position 2 meters. Time 2 seconds, I'm at position 4 meters. Time 3 seconds, I'm at 6 meters. And then time 4 seconds, I'm at 8 meters. And then I could connect those all with a relatively straight line. All right, my next step is to make quantitative velocity versus time graph. In order to do that, I really have to think about the slope of my position versus time graph. And I can see that for every 1 second, I was increasing my position by 2 meters. So I know that the slope is 2 meters for every second. I also can look back at my motion map and look at the length of my arrows, and I can see that they are 2 meters in length. So I can figure out that my velocity is 2 meters for every second. You can see right now I'm scaling also my velocity versus time graph. So my velocity is 0, 1, 2, -1, -2, and then times 1 through 5. The slope of my position versus time graph is equal to the y-intercept of my velocity versus time graph. Because the velocity isn't changing, I'm going to have a straight line from time 0 to time 4. Now, why only to time 4? Because my motion map and my position versus time graph stop at time 4. Next up, I'm going to be writing a math model. I'm going to use x to represent position, and my slope of my line is 2 meters for every second. On my x-axis is time, plus my initial position is 0 meters. On my velocity versus time graph, I'm going to say velocity equals, my slope here is 0, and the unit is going to be a little bit funny. It's meters for every second for every second. Time is on my x-axis, and I can see that my y-intercept is going to be 2 meters for every second. My last part of this worksheet, on this page at least, for number 2, is find the area underneath my velocity versus time graph. What are the units of this area, and describing what that means. I'm going to change colors for just a moment. So what I'm trying to do is I'm going to try to figure out the area of this section right here. And it's always from the 0 line. I'm trying to figure out from the 0 line up to my velocity versus time line. So this whole section here. And you're probably noticing right now that this object this area is the shape of a rectangle. And I know that in order to solve for the shape of a rectangle, I'm going to do base times height. Now my base, I can see, is 1, 2, 3, 4 seconds times my height, 1, 2 meters for every second. And just thinking about 4 times 2, I know is 8, but also seconds times meters per second, my answer is going to be 8 for the number, and then my unit is going to be meters. And then it says, describe what this area represents. I'm not going to answer that part because I think you can figure that out on your own, but it might help to look at this value and look back at both your position versus time graph and also your motion map. All right, good luck.